In this video, we're going to talk about setting up a decryption policy on the Palo Alto. Now, I know in the past you've always been told that SSL decryption is impossible and that as long as you are on a website, you should be looking for this nice big lock icon on your web browser, and that means that this is in fact secure and free from hackers. However, that's not always the case. There is a way to be able to do what's called a MITM or man in the middle attack that allows a hacker or a security engineer to be able to review what's happening on those secure channels. And that's exactly what we're going to do here in our Palo Alto, is set up how we can be able to identify what's happening under those SSL and TLS encrypted connections so that we can then see what data is in there. And this is important in a lot of organizations because a lot of times you are concerned about what data your clients might be sharing, what data your employees might be sharing. For instance, if I go to facebook.com, is somebody sharing private secrets? Or more specifically, are they sending out maybe social security numbers or credit card numbers or some other private information that shouldn't be shared in my environment, either on Facebook or other social media or anywhere else in the internet? And so by reviewing what's happening in these SSL and TLS encrypted connections, I can then identify, oh, Sally sent up some information about social security numbers. I was only able to find that because I was able to decrypt their traffic as it was going through the internet. At that point, you can then go back to Sally and say, why are you sending people social security numbers or credit card numbers or HIPAA information or other private information that shouldn't be shared with the public? So SSL decryption, in theory, it's unbreakable, but it turns out it's actually not that hard by design. This is not an accident. This is not a hack. This is not an attack to your environment. This is a design that you can put into your system. So the way this works, let's talk first about a proxy server. Now, before we talk too much about a proxy server, let's go back to when we were in elementary school. There was a cute little girl in elementary school. Let's call her Sally. And so I was way over here. I was kind of the weirdo. And I liked Sally. And I wanted to talk to Sally, and I wanted to see if Sally liked me. However, I could not, for the life of me, talk directly to Sally. I just couldn't do it. But I was too nervous. It was elementary school. It's your first crush. How do you actually talk to somebody? So instead of me talking directly to Sally, what I do is I find a friend named Tom. These are all fictitious people, by the way. I do not recall ever knowing anybody named Tom or anybody named Sally. What I would do is I would say, hey, Tom, can you talk to Sally and see if she likes me? Tom then goes over and talks to Sally and says, hey, Sally, Ed likes you. Do you like him? And Sally says, yes, Ed is the greatest person in the entire world. I want to be with him forever and give him all of my chocolate milk. Tom then comes back and hopefully repeats back what Sally said correctly so that I am then very happy. And at that point, I can then, either keep continuing to talk through Tom or talk to Sally directly. In this case, Tom is a proxy. Tom in this situation is doing something on behalf of somebody else. He's acting as a proxy for me to Sally so that he can help me have that conversation. And that's exactly what happens on the internet. Me over here on my client, instead of talking directly to a web server, I talk to a proxy instead. That proxy can then give me lots of great features, such as helping protect me, help minimizing all my bandwidth, and allowing me to, hopefully be more secure in the world. So because I don't talk directly to the web server, I instead talk to the proxy, and then the proxy talks to the web server on my behalf. When the web server returns a response, the proxy server turns around and sends that response to me. Now, like I said, if that web server has been accessed a whole lot of times, say it's the day right after the Super Bowl and everybody's going up to YouTube and downloading videos of all the great commercials that were on the Super Bowl, that proxy server can actually speed up those downloads by proxying or caching all those transactions for me. So this is how a traditional proxy server works in the computer world. What we can do is, if we start adding in some certificate magic, what I can do is my client, instead of talking, let's see, if I do some certificate magic on my proxy server here, when my client connects to the proxy server can send back a local certificate. There we go. And that local certificate allows me to create an SSL/TLS connection locally between me and the proxy server. Great. So now I've got a secure connection to my proxy server. The proxy server then goes out to the internet and says, hey, Mr. Web Server, I want to make a connection with you. The web server turns back its certificate, which then creates an SSL/TLS connection right there. So because this proxy server is sitting in between me and my destination, I have essentially two SSL sessions right here. I have session number 1 and session number 2. My client only knows about session number 1. The proxy server then communicates with the web server on session number 2. Both sides of those communications are secure. And then right here on the proxy server, it can be decrypted. When it's decrypted, I can then start analyzing it. Maybe I want to start looking for all the great phishing spots that all of my employees are talking about. So I can then start looking and telling my proxy server, decrypt anything having to do with phishing, any websites or message boards people are going to talking about phishing, and decrypt it and then capture that data and send it to me so that I then know where Joe is going fishing this weekend, so I know what a good phishing spot might be. And that's exactly how decryption works in a Palo Alto environment. Is it actually sets up two SSL sessions with two separate sets of SSL certificates. By the way, I'm saying SSL, TLS. SSL is the older version of the technology, but it's still what most everybody calls it. So if I say SSL, I mean both SSL/TLS. So what we're going to do here in this Palo Alto, we are going to set this up with some SSL certs. And then we're going to configure this guy as a proxy to decrypt that data that's going out to the cloud, out to the internet, and then be able to inspect any of that data that's going back and forth between my clients over here and the internet. So 4 easy steps. We start off by creating a certificate, either create or set up a certificate on the Palo Alto. If this was a proper enterprise, I might have an enterprise, enterprise certificate authority, or enterprise CA, in which case I would use a certificate from the enterprise CA. In our lab, we don't necessarily have one of those, so we're going to go a cheap and dirty way of using a locally created certificate. Once we've set up that certificate, we then have to configure the clients to trust that certificate. Just because we have a certificate doesn't mean that they trust them. By the way, if any of these certificate or encryption policies are confusing, feel free to read up on certificates. PKI is probably the area you're looking for. PKI, private key infrastructure. So once the client is set up to trust the certificate, we define a decryption policy, and then we can confirm whether it's working. So let's go ahead and get started with setting up a certificate on our Palo Alto. So here I am, I'm on my Palo Alto management system. And I'm going to go ahead and start setting up our certificate. In order to do that, we come up to Device. And then over here on the left-hand side, we can start seeing we have a section called Certificate Management and Certificates. Imagine that, we're going right there. Now there's currently no certificates, so what we want to do is generate one. Now, obviously, if you had an enterprise CA, you would not be generating these. Obviously, maybe not obviously. If you have your own enterprise CA, you would not be generating, you would be importing. But for now, we're going to go ahead and generate. Let's go ahead and give this a name and common name. So let's see, for name, let's call this outbound certificate. That is the name that will be viewed in the Palo Alto, and then the common name, which will be shared with all of our clients. Let's call this Palo Alto Firewall Cert. We want to go ahead and mark this as being a certificate authority. It's a self-signed certificate, so we want it to be a certificate authority. We can change the cryptographic settings here. For now, I'm going to leave them as is. Obviously, the bigger, the better. But for now, that is fine. And then let's add in some attributes. These help identify what our cert is and whether they should trust it. So let's see, country, United States, state. This is the state of Washington that I'm in anyway. Let's see, organization, I'll go ahead and just type in edgo.com, and we can keep going here with adding more and more attributes to make it more and more specific to our needs. That's about all we need right now, so I'm just going to go ahead and say generate. There we go. So it successfully generated the key. I do need to make a couple of edits to it, so I'm going to go ahead and click on the name right here. And these three checkboxes down here, forward trust, forward untrust, and trusted root, I want to go ahead and check those three. Not too much to worry about at this point. Basically, forward trust, if this is a site that they should be trusting, use this cert. If it's a site they should not be trusting, use this cert, and then this will become a trusted root CA in just a couple of minutes. There we go. Okay, so that's step number one. That was step number one of our 4 easy steps right there. Oops. Yeah, so right there, that was done. That was our first of the 4 easy steps. Step number 2 is to configure our clients to trust the certificate. Now, in order to configure the clients to trust the certificate, what we need to do is we need to export this certificate and then import it on our clients. Because of how our network diagram is laid out, that would make things a little difficult from this point of view. So what I'm going to do is I'm actually going to go over to our client, specifically PC number 1 here, and go ahead and log in. And from my client, I'm just going to go ahead and log right into the Palo Alto. 172.31.199.70. So talking about certificates, right here is one of the issues you'll probably see with other certificates. This is saying, hey, this is an insecure site. We don't know who this certificate. We don't trust it. We always tell our clients, ignore this, or don't ignore this, excuse me. This means something's wrong. Run away as fast as you can. In our scenario, we know that this is going to happen. So we're going to go ahead and click details and then go to web page. At this point, we can go ahead and log into the Palo Alto. This will take a couple of minutes as it's logging in. What we're going to do, since we're on the client, we're logging into the admin portal here simply so we can download that certificate. Once it's downloaded, then we can import it and say, yes, this is a trusted cert. Let's see. There we go. So we're right here on step number 2. Or configuring our clients to trust the certificate. Now, this would be done differently if this was an enterprise environment. If there's more than one client, you have to figure out a way to be able to get this certificate on all of these clients and trusted. That's a whole nother class. That might have to do with Windows certificates, Windows group policy, Linux automation, all depending on the operating system you're running. But unfortunately, out of the scope of this video. So we'll go ahead and we're back to our PC right here. Want to go back to device and certificates. And I want to highlight the certificate and then just click export. I don't need to export the private key. It's always best practice to actually do that and store that in a secure environment. But for here on our client, we don't need it. So I'm just going to say OK and save. So I went ahead and that saved it. At that point, I am done with the web browser on this client. What I'm going to do is I'm just going to import that. Let's go to downloads. There's my file right there. If I just double click on it, it opens it up. And then I can click install certificate. It says, where do we want to store it? Do we want to store it in the user or the machine? Probably want to put this in the machine so that everybody who uses this machine gets the certificate as opposed to just the current user. So next. It then says, which store do we want to put this in? We want to choose, and we want to put this in the trusted root certificate authorities. Trusted root means that all the certificates that come from these people, all the people that created the certs that are in here, will be trusted in the future. So that's where we want to put that. Next, and finish. There we go. So our certificate has now been configured on our client. A client is trusting it, and we are now ready to move ahead to step number 3. Excuse me. Step number 3, setting up a decryption policy. So the decryption policy is where some of the interesting things start coming up. What we want to do here, let's see, under policies and decryption. I'm going to go ahead and add a decryption policy. Let's just call this internet decryption. And we specify the source zone. In this case, we want that to be our private network. We could specify specific addresses or users as well. We then specify the destination zone, which would be public. So anybody going from private to public. And again, we could specify specific IP addresses. Service and category. Services, we don't necessarily want to specify any particular services, so we'll leave that to any. There we go. And then URL category is probably where the big questions really come in. Of what data do we want to decrypt, and more specifically, what data do we not want to decrypt? So for instance, if we look in here and I start typing in fin, we can see one of the options here is financial services. Now, financial services is a questionable thing. Do I really want to decrypt this data? Do I want to see all the data that my employees are sending when they're accessing their bank accounts or when they're accessing their retirement accounts? Probably not. I mean, it would be maybe personally interesting to see from kind of a voyeuristic standpoint. However, from a security standpoint and from a do you really need to know that information, financial services probably are not the areas that I want to look into. So what I want to do is I want to actually start looking at maybe social media. There we go. Social networking. Social networking might be something I want to look at. I also talked about phishing. So that was, there we go. Hunting and phishing. So maybe I want to start decrypting the data for social media sites and for hunting and phishing sites, just so I can see that information to make sure that there's no For instance, under social media, nobody sending out questionable information on social media pertaining to be my organization. And then hunting and fishing, because I want to know where all the good fishing spots are. Finally, we go to options and we say, yes, we want to decrypt and type of SSL forward proxy. All right. Last but not least, we need to change our security policies just a little bit, because if you, at least in my security policies here, my private to internet access has some restrictions on social media sites. So what I want to do, actions, I currently have a profile group that blocks social media sites. I'm just going to turn that off. I'm just going to set that to none so that everybody is allowed to all sites. In fact, actually, before I do that, let's go back to applications. I'm going to add in Facebook. And OK. Commit. And commit. So previously we had blocked Facebook. We had blocked social networking, social media sites, simply because we didn't want our users going to those sites. So maybe now we're changing our policy. It's okay to use those social media sites. Dependency warnings. All right, MQTT. So maybe, we've changed our point of view. Social media sites are allowed. However, we are going to review what that data is so that we can then confirm that you're not sending out any proprietary information or any details you shouldn't be sending out. Facebook voice, that's fine for now. If I cared about Facebook voice, I would add RTCP, RTP, and it's done. All right. So that was step number 3. The very last step is to confirm that the decryption is working. So for that, we will go back to our PC right here, and we'll open up a web browser. And let's just go to facebook.com. So we are now on facebook.com, and you're thinking, yeah, everything is perfectly fine. Everything's working exactly the way it's supposed to be. I'm looking up here up at the very, very top of the screen, and I see my little lock icon. That means it's encrypted, which means I am secure from point A to point B, or from end to end. However, this is where the interesting parts come in, is if we click on that little lock icon, it gives us details about our site, about our security. And you'll notice right here, this has been confirmed secure by the Palo Alto firewall certificate, the certificate that I created. Remember that whole little diagram I drew up, or I showed, where we had our client and then our our web server out here. That's supposed to be a web server. www, and in between there was a proxy server. And what happened was my client talks to the proxy server and has his own SSL connection right there. The proxy server then talks to the web server for me and has its own SSL connection right here. And what happens is the Palo Alto says, yes, this connection is secure. So I will go ahead and I will secure this connection over here with my own SSL certificate, and therefore it appears fully secure to the end user. However, on the firewall server, on the proxy server or the Palo Alto firewall, it is decrypted and inspected. And at this point, I can start looking through that encrypted and inspected data for interesting information, such as passwords and SSL certificates and viruses. Yeah, viruses can be spread via social networking. So if I'm decrypting data through social networking, then I can start decrypting data decrypting that data and inspecting it for viruses, inspecting it for malicious information, for malware, or for other insecure items such as social security numbers and credit card numbers or other proprietary information to my organization. So there you have it. You have decryption, SSL decryption in our Palo Alto firewall. And this is not just an accident. This is by design in order to allow us to be able to see what's happening and secure our environment as best as possible. So 4 easy steps: set up the certificates, configure the clients to trust it, create a decryption policy, and be careful what areas you decrypt and more specifically what you don't decrypt. Last thing you want to know is to have somebody come after you because you have some HIPAA information or other PII on your firewall. And then lastly, go ahead and confirm the decryption is working for some sites as opposed to others. So for instance, if we go to a different website, let's say paypal.com, and then we look at the certificate here. Here the certificate says this is verified by VeriSign, as opposed to our Palo Alto firewall, which we personally created. So quite a few steps, or only a couple of steps in order to get it to work in your environment. It could be quite a few depending on this right here of how you get the clients to be able to trust it. But otherwise, it's a great man-in-the-middle configuration to help secure your environment.